Okay, I think I'm back here. All right, internet just went out here. It looks like I'll be doing 2 videos this week apparently. So here we go. I don't know if you guys caught my start to this problem right here. So let's go ahead and say our first strategy for this guy is going to be that we are going to hit this guy into sines and cosines here, right? So strategy number one, let's go ahead and rewrite this guy as a tangent is sine cubed over cosine cubed times our 1 over cosine cubed that we have from the denominator here. And so it seems like we can write this as sine cubed over cosine to the sixth dx, right? So what I'm thinking now is I feel like I can do some u sub here because I got some sine parts and I got some cosine parts, right? So I'm going to go ahead, and this is one of those places where I do this thing all the time right here where I say, all right, let's go ahead and hit this thing with a u sub. My instinct is always to pick u to be sine because that just makes du cosine. And then I'm looking at this right here, and it seems like it seems like this is not quite our right way to do this thing right here. Notice that my cosine parts are denominator, but my dx is always numerator. But here I need cosine times dx, and we don't quite have that right here. So actually, it seems like that's my wrong way to build my u sub for this guy. I think I actually want to flip this guy around and do u being cosine of x and du being negative sine x dx. The reason why this is going to work out better is because sine is part of the numerator up here, as is dx, and so these are multiplied. Sine and dx are multiplied together, whereas cosine and dx were not multiplied together right there. So let's see what we get when I go ahead and attempt to do this u subbing right here. So what I'm seeing is this. What I'm seeing is cosine to the sixth is clearly turning into u to the sixth on the bottom. I'm seeing that, and maybe I want to write this as my negative du is sine x dx. It seems like one of the three signs is going to partner up with the dx to become negative du, so I'm going to get my negative du, but I still have remaining a sine squared of x on top, right? We only used up one of the three to swap out for du. So, are we stuck? Well, no. We love our even powers of trig functions right here. It seems like I can now go ahead and swap out our sine squared for a 1 minus cosine squared. And now we're back into being able to continue on with our substitution here, right? Now we should be getting the negative integral of 1 minus u squared over u to the sixth du. Right? So using our even powers, love those even powers of trig functions, right? So now it looks like, what am I getting? Negative integral of 1 over u to the sixth, and then it'll be plus the integral of 1 over u to the fourth. So two things right there. U squared over u to the sixth is u to the fourth. It was a negative, but I also distributed the negative outside through, so that became positive, and now this one is the negative that's right there. Oop, forgot both my du's right there. Don't forget those guys. And now we're in good shape right here. This is really negative integral of u to the negative sixth du plus integral of u to the negative fourth du. And now I'm just integrating. It looks like this route was a good route to go. I'm going to go ahead and add 1 to the power. So this is going to become a u to the negative fifth. But I also know that I need a negative 1/5 out there to counteract that when I take the derivative. So it seems like I would be getting a positive 1/5 u to the negative fifth for that guy. Similarly over here, I'm going to add 1 to the power. So I'm going to get a negative 3, but I need a negative 1/3 to counteract what I'd get from the derivative here. And so it seems like I'm going to get a minus 1/3 u to the negative 3. And so I'm remembering here that u was cosine for our correct one right there, our good u sub that we did. And so I just got to plop back in my cosines here. So I might write my final answer here as 1 over 5 cosine to the fifth of x minus 1 over 3 cosine cubed of x plus c. That seemed not too bad right there. Our converting into sine and cosine in this case turned out to be a reasonably good strategy. But again, that converting everything to sine and cosine is less of a good idea in calculus than it is just in trig class right here. It always doesn't always work out so awesomely like that one did right here. So let's see what we would do if we didn't do the convert into sines and cosines. Instead, there is a proposed trigonometric modification that we should be doing right here, which would be to say, Let's rewrite this in terms of tangents and secants instead, and then follow the advice from the u subsection here. So strategy number 2 is going to say, and I'll rewrite our original one right here. We started with our tan cubed x over cosine cubed of x dx. Well, another way that I could think to write this is as our integral of tan cubed, oh, that's not how I want to write this. All right, this is just tan cubed of x times 1 over cosine cubed dx. And that's really secant right there, right? So it looks like we're really writing this as the integral of tangent cubed secant cubed. Gosh, I wish it was easier to write over the top of my writing sometimes here. There we go, dx. Now, if we go and reference back to our previous section in the textbook that says what our advice is for this section, when we see our powers of tangent and secant being multiplied, their advice is we should pick off a tangent squared, leave one grouping of the tangent secant left alone, and do our u sub with secant, because the derivative of secant is secant tangent. So what I want to do is I want to get a secant tangent to hang out with dx, because I'm going to use u equals secant as my substitution. So here's the way I'm going to rewrite this guy. Tangent squared, secant squared. I've picked off one tangent and one secant because those are going to buddy up with the dx. All right. Now I'm going to go ahead and make my substitution here of u equals secant. The whole reason we picked this is because du is going to be secant tangent. And so I was building for myself the du term I wanted right there, right? The whole strategy here was saying, if I'm going to pick u to be tangent, then I'd need a secant squared to go with it. But if I picked u to be tangent, then getting a secant squared leaves us with a single leftover secant. And we don't like first powers of trig functions. On the other hand, if I pick u to be secant instead of u to be tangent, then this gives me a du of secant tangent, and it leaves us with 2 even powers of trig functions. And we love even powers of trig functions. So that's what our strategy choice was right here. You should, again, I think it's worth it to stop and do u equals tangent of x and see why that's going to be tougher to work with there. It's going to leave you with that single secant, and a secant to the first power that's being multiplied by other stuff is not something I can handle here. All right. So proceeding on with this guy, it looks like what I've got is our integral of tangents. Come on. So I've got my tangent squared of x. That doesn't have a substitution term yet. It looks like this is going to be times u squared, and all this over here is just du. So it looks like I need to be able to rewrite tangent, but the good news is that tangent gets rewritten as secant squared minus 1, right? Tangent is secant squared minus 1. So it looks like if I'm going to wrap this guy up, it looks like this is really the integral of u squared minus 1 times u squared du, which I can rewrite as u to the 4th minus u squared du. Couldn't get any easier than this. 1/5 u to the 5th minus 1/3 u to the 3rd. Boy, do these terms look familiar relative to our previous version of this problem. And notice the difference here. Check this difference out. The first version of this problem, our u sub was to make u cosine. The second version was to make it u equals 1 over cosine. Instead of getting negative powers, we got positive powers. Everything totally matches up right here, right? So this is 1/5 secant to the 5th of x minus 1/3 secant to the 3rd of x plus c. And we recognize this to be exactly what we wrote a moment ago. Because I rarely leave my answers in terms of secant, because I don't want to have to do math with secant. I like my sines and cosines. It's my comfort zone there, so I typically head back into it right there. So, pretty cool. 2 totally different strategies for this problem. One was algebraically rearrange, do our trigonometric rearrangement, and to do a u sub with cosine. Our alternate format right here was to do to follow our book suggestions for our trigonometric integrals as to grouping up our evens and our odd powers. Notice that we didn't really reference the strategy associated with even and odd powers up here. This was just get it in terms of sine and cosine and u sub, because sine and cosine are derivatives of one another. So you always have two good u sub choices depending on how they're arranged. Down here, we've been given explicit strategies associated with products of powers of tangent and secant. I'm just following the book strategy guide right here. It said, listen, if you have odd powers of tangent, you want to do u equals secant tangent so that your du is going to be, or sorry, u is secant, so that your du is secant tangent, so that one of the tangents is used up, giving remaining with an even power of tangent left over. There's all these strategies for saying, since even powers are our friends of trig functions, we want to do the substitutions that are going to lead us towards those. So the even odd power type of stuff. And again, I'm going to again be honest with you guys. I don't explicitly remember what all of our suggestions are right here, but because I remember the general spirit of these things, like we love even powers of trig functions, I am always thinking to myself things like, whatever sub I'm making, my goal is to pick off parts to leave a bunch of even powers that are out there. So it's true that even if I hadn't looked up what to do for this one in the textbook, I still know what my two guesses are. My two guesses are either u is going to be tangent or u is going to be secant, and the one that I want to choose is the one that's going to result in me having a clean du and having some even powers left over of my remaining terms so that I can convert one trig function into another with a Pythagorean identity right there. So since I see the big picture on what trig subs are doing, it matters less to me that I directly remember the exact strategy that I should pick. And again, I'm going to roll back up here and say, I don't care if you guess wrong. I really don't care if the first thing you did was u equals tangent of x for that problem and then you realize you couldn't make it happen that way. Nobody cares. Just try the other thing. It doesn't take that much effort to try a u sub, see it was the wrong one, and try a different u sub out there. That is a trivial amount of effort that has been wasted right there. We got to maintain our endurance and just try the next thing, right? So with these strategies for integration, and by the way, I'd suggest for you to also think of another thing. Picture us being in class in person this semester, and picture me giving you a sit-down hour and 15-minute take-home test where you don't get any notes. What are you going to do? Are you going to memorize every single suggestion the book has made for us over the last two chapters? I would hope not. I would hope that you would just try things until you get it. That is the most important strategy that we have here this semester. Try harder. Cool. So we got this answer two different ways. Let's go ahead and hit our last integral of the day right here. And I'm going to tell you, we're going to do this a kind of smart way the first way, and we're going to do it a little bit dumber of a way the next way right here. And it's gonna be an integral. That's for dang sure right here. So the first thing that I'm thinking when I see this guy is, I don't know what the heck I'm doing with this guy. The reason why this one looks tough to me is because the entire expression is one gigantic square root. In fact, I'm very comfortable saying it's not clear to me at all that this is an integrable function. But if I were to just try some stuff, what would I try, right? Well, the thing I'm seeing here is it's quite a bummer that we have these, everything's underneath a square root. And I'm like thinking to myself, man, it'd be pretty cool if there was some parts that weren't under a square root here. And so my question to you is, do you know any way to alter a square root expression so that you end up having it be squared without really alternating what the expression actually is representing? Coming up with an alternate form that does introduce some squaring? And I think that the answer is yes. I think that I know that conjugates are a good way for me to effectively square certain values. Although I'll say, not clear to me what conjugate I should be using in this case right here. So what I'm thinking here is for strategy one, I am thinking to myself, I know that, for example, the square root of x over y, we can always write as the square root of x over the square root of y. It seems to me like I can rewrite this as the square root of 1 minus x over the square root of 1 plus x, but it's not clear to me which of these I'm going to want to like hit with the conjugate, right? Should I be doing the 1 plus x conjugate or the 1 minus x conjugate? I'm actually not really sure, so let's check them both out and see what we end up getting here. If I do my square root of 1 minus x over square root of 1 plus x, one thing I could do is I could hit it with the 1 plus x over 1 plus x. The other thing I could do here is take my original expression and do 1 minus x and 1 minus x. not 100% clear which one I want right here, so let's take a look. If I do this, the product of two factors that are underneath the square root, we do the multiplication underneath the square root. So it does look like I'm going to get a square root of 1 minus x squared on top. Bottom, it looks like we're just getting straight up 1 plus x. If I compare that over here, it looks like in this case, oop, that's not a times sign. I should get my notation right. That wasn't the times. That's equal to. On the other hand, a different way I could think to manipulate this would be to do the alternate conjugate right here. In this case, it looks like the numerator is what we're getting just a nice square of, so it pops out of the square root. And in the denominator down here, I'd be getting my 1 minus x squared. This to me looks like more closer to the format of the trig subs that we've seen, because I know that I could rip this guy apart. This one I don't know about right there. So I'm going to say, let's go ahead and do this guy right here. I kind of think that that's maybe a good alternate version for this integrand right here. So notice that I've just hit my integrand with a conjugate. All I've done is multiply it by 1, so we're still good to go. But it looks like I can now say that this is equal to the integral of 1 minus x over the square root of 1 minus x squared dx. And so again, I want to really emphasize, I don't know what I'm doing here. I'm just trying stuff. I'm just flopping some work out on the page and being like, if I had to pick between those two, which one do I think is more likely? I'm not even saying I know that this will work. I'm just saying it seems to me like it's more likely that this is going to be good for me than this. And if I get really stuck here and this doesn't work, then I'll come back to this expression here and see if I can make something happen with this guy. I'm just trying to order what seems to be most likely to least likely. I never know what I'm doing. I am flailing around just like you are, I promise. This is just trying stuff. I just got to flail around before I did this problem, and you're just seeing it for the first time. That's the only real difference right here. So what I'm thinking to myself is, it seems like I can separate this over the numerator as 1 over square root of 1 minus x squared dx minus the integral of x over square root of 1 minus x squared dx. Right? And the good news about these guys is it looks like they're both following this exact same format. In fact, we're going to want to make the same trig sub in each of these cases right here. So same format under radical.